November 4th, 2025, exactly 72 hours after disappearing behind the sun during its perihelion passage, an object from another star system has returned to view, transformed. It is brighter than before. It is accelerated in a way that no gravitational model can fully account for. And perhaps most unsettling of all, it has shifted in color, glowing blue where all conventional physics says it should glow red. You are witnessing a moment in astronomy that almost no one expected, and even fewer are actually paying attention to. But if you're watching this, then you are among the rare few who are not willing to look away. This object is known simply as 3I Atlas, the third confirmed interstellar visitor to enter our solar system. And with its re-emergence, it has brought data that could push the boundaries of astronomy, physics, and even our understanding of what can and cannot exist in the space between stars. Because what 3I Atlas just did is not only unexpected, it is, by all current models, impossible. Let's begin with the impossible acceleration. As 3I Atlas approached perihelion, the point of its orbit closest to the sun, it began to deviate from its predicted trajectory, not by drifting randomly, but by accelerating in a smooth, measurable, continuous way. This is what scientists refer to as non-gravitational acceleration, a term that sounds clinical, but in truth points towards something deeply unsettling. Some other force, some unseen process, was pushing it. Now, non-gravitational acceleration is not unheard of. Oumuamua exhibited similar behavior in 2017, but where Oumuamua was accelerating while growing dimmer, 3I Atlas is accelerating while becoming brighter. That is not normal. In fact, it's the opposite of normal. Because after a comet passes perihelion and loses volatile material, it should dim, not shine. And yet the exact opposite is happening with 3I Atlas. Just days after its closest pass near the sun, it is not only glowing brighter, it is glowing bluer. That small detail alone should feel like a crack in our cosmic certainty. Because comets don't turn blue. Blue means ionization, an emission of energized gas or plasma. In comets, it's usually the faint result of carbon monoxide or nitrogen. But this blue is stronger, persistent. The spectral readings collected by amateur and professional observatories alike do not fit easily within any standard outgassing profile. It's almost as if the comet were undergoing a transformation. Or worse, as if something within it has been triggered. The moment we allow ourselves to accept that 3B Atlas is behaving unlike any other comet in history, we have to accept the consequences of that admission. Something is wrong with our model. As Professor Brian Cox once said, the universe is not required to be in perfect harmony with human ambition, meaning the universe does not bend itself to our ability to understand it. And right now, 3I Atlas is quietly reminding us of that uncomfortable truth. What makes this moment even more extraordinary is its timing. As of the moment you're watching this, we are inside a narrow, fleeting window of scientific opportunity. The data arriving from observatories in Chile, South Africa, and the United States are confirmed and synchronized. NASA and ESA are officially monitoring. Spectral readings from the Swift Observatory and JUICE spacecraft are showing deep inconsistencies with both dust-dominated comet models and volatile-rich models. We are standing on the threshold of discovery, and yet mainstream awareness is nearly zero. That is why this video exists, not to entertain, not to speculate recklessly, but to document the real-time unraveling of an astronomical anomaly, and to walk you through the evidence piece by piece, layer by layer, without resorting to conspiracy or sensationalism, only with one core promise, that the truth, whatever it is, will emerge from the data. If you are still here, if you have not scrolled away, then you are already part of the small global network of observers who refuse to look past this, who refuse the comfort of not knowing. If that's you, leave a comment below with your location, not because the algorithm asks for it, but because data matters. Where you watch from can be a node in a web of witnesses. History does not belong to crowds. It belongs to those who showed up. Now before we proceed further, there's a critical distinction to make. Nothing so far about 3I Atlas confirms the presence of artificial technology, alien propulsion, or purposeful maneuvering. Those ideas, while exciting, have no evidence. Yet, what we do have is confirmation of behavior that cannot be adequately explained by existing physical models of comets, meteoroids, or interstellar debris. There's no need for exaggeration. The truth is already shocking enough. Perhaps the most haunting question is this: what changed behind the sun? During those 3 days of solar blindness, something happened to 3i Atlas. Something powerful enough to alter its brightness, its vector, and its physical structure. And whatever that something was, we missed it. No optical telescope on Earth could see through the solar glare. All we have now is the aftermath. With that in mind, this investigation begins. Over the next 24 parts, we will follow the data, build the timeline, evaluate the hypotheses, and push each theory to its breaking point. Not because we seek a specific answer, scientific process has no desire, no agenda, but because the integrity of discovery depends not on what we want, but on whether we are willing to follow where the evidence leads. To quote Brian Cox once more, "Curiosity is the reason we came down from the trees, and it is curiosity that will carry us into this unknown." This is not just a video, it is an observation log, a real-time archive of something happening in the cosmos, something that may reshape the way humans understand the unfamiliar. Take a breath, keep your mind open, and remember, this moment is not coming back. We'll begin with the first observable irregularity, the acceleration that should not exist. Before we proceed to explain what 3i Atlas is doing, we need to establish a simple but essential foundation. What we are seeing is not speculation. It is not a glitch in the data, nor the miscalculation of a single telescope operator. What is unfolding across our sky has been confirmed, independently, repeatedly, and across 3 continents, by sources that have no reason to conspire or exaggerate. This is not conjecture, this is observation. Within hours of 3i Atlas re-emerging from its 3-day blackout behind the sun, data began to flow in from observatories across the world. Lowell Observatory in Arizona, represented by astronomer Chi-Chang Jiang, was among the first to release post-perihelion imagery, high-resolution CCD captures, showing a luminous, asymmetric coma that retained a blue spectral dominance. These were not fuzzy, uncertain glimpses. They were crisp, calibrated, measured, and they were quickly cross-referenced by 2 other professional sites. On the other side of the Earth, the South African Astronomical Observatory, SAAO, confirmed the same anomalous readings in the early morning hours of November 1st. Using a different hemisphere, a different angle of sky, and most importantly a different instrument suite, they replicated both the non-gravitational shift in trajectory and the post-perihelion brightness spike. The shift was small, measured at around 0.02 but it was unmistakable. As the team lead put it, whatever is happening here, it is persistent, and it is not random. Across the Atlantic in the frigid Atacama Plateau of Chile, the European Southern Observatory, ESO, delivered the 3rd layer of confirmation. Their spectroscopic analysis, conducted in near-infrared and visible light, confirmed not only the blue-shifted emission pattern, but a deviation in the coma's density profile, suggesting either internal fragmentation or an active outflow process not present prior to perihelion. Then, there's the data stream above Earth. NASA's Swift Observatory, currently operating in ultraviolet and X-ray bands, has detected elevated OH emission lines, typically a sign of sublimated water, but at energy levels inconsistent with a passive ice melt. At the same time, the JUICE spacecraft, which had an observational angle free of solar interference, tracked a slight but measurable rotation change in the object's spin rate. Not dramatic, but enough to register. When 4 instruments, optical, spectroscopic, ultraviolet, and spaceborne telemetry, all agree over thousands of miles in 3 continents, we are not dealing with instrumentation failure. We are dealing with a real physical event. NASA's official stance is cautious but clear. Multiple ground-based facilities and spacecraft assets confirm observed non-gravitational perturbations in the motion of 3i Atlas. Ongoing analysis is required. They are not dismissing it, they are documenting it. The European Space Agency, ESA, has taken a similar tone, issuing a technical footnote in their November 3rd bulletin. Observed acceleration of 3i Atlas inconsistent with standard gravitational modeling. Further spectral analysis underway. What we are left with, therefore, is not a theory, but a stacked tower of data layers, agreeing across institutions and geographies. And that matters, because in the world of science, truth is what survives replication, and 3i Atlas has now been replicated, confirmed, peer-validated in real time. Let me emphasize this point clearly. because this is exactly where the investigation takes its first real step. You do not have to believe in aliens. You do not have to believe in anomalies. You only have to believe in measurement. No single observation could have carried the weight of this moment. But when Arizona agrees with Chile, and Chile agrees with South Africa, and South Africa agrees with a fleet of spaceborne instruments, you no longer have a rumor, you have a report. And that report says, 1. The object is accelerating in a way not predicted by orbital physics. 2. The object is becoming brighter when it should be dimming. 3. The object is emitting a wavelength signature that does not map cleanly to standard comet composition. 4. The object has not broken apart, but it is changing physically. This is the first threshold of scientific confidence. Not belief, not narrative, just data. Hard, repeatable, professional data. At 11:15 UTC on October 29, 2025, 3i Atlas reached its perihelion, the moment it passed closest to the Sun. A timestamp that, for most comets, is nothing more than a line in an orbital chart. But for 3i Atlas, that moment became the pivot point between what we thought we understood about interstellar objects and what we are now forced to confront. Because at perihelion, 3i Atlas was not only intact, it was moving at 68 kilometers per second. Try to feel that number instead of reading it. 68,000 meters per second. That is fast enough to cross the entire width of the continental United States in under a minute. From New York to Los Angeles. Faster than it takes you to form a thought. No aircraft, no missile, no technology on Earth even approaches this. Only celestial mechanics can produce such motion, and yet here is where it gets strange. Because the speed is not the anomaly. The anomaly is that it didn't slow down after perihelion. In fact, all current measurements suggest something far more unsettling. It may have begun to accelerate. This is where the comparison becomes unavoidable. Imagine a car coasting down a steep hill, gravity doing all the work. The moment it reaches level ground, it should start losing speed. But instead, its speed increases. No driver, no engine, no visible force. That is what's happening with 3i Atlas. And what of its distance from the Sun? At perihelion, it was just 0.74 AU away, 3/4 the distance between Earth and the Sun. Any normal comet would begin to shed its outer layers, venting dust and gas in a chaotic tail, growing dimmer and redder as it loses mass. But 3i Atlas didn't lose mass. It didn't dim, it brightened. A smooth, measurable increase in luminosity, not caused by fragmentation or dust emission, but by a strengthening of its blue spectral profile. This is not normal behavior, not for a comet, not for an asteroid, not even for the two interstellar objects we've seen before. Oumuamua in 2017 and Borisov in 2019, 3i Atlas isn't just another entry in a new cosmic catalog. It's an outlier even among outliers. Because what happened at 11:15 UTC wasn't just a gravitational milestone, it was the moment its real trajectory began to diverge from the one predicted by physics. A moment when the curve broke. Slightly at first, just enough to raise an eyebrow, but a deviation that, if allowed to play out over weeks or months, could grow into a path impossible to align with Newton, Kepler, Einstein, or any of our current models. And that's what makes this moment so important. Perihelion wasn't the end of the story. It was the trigger point. The moment the comet was expected to behave like everything else, and instead, behaved like something new. So now the question shifts. Were we simply watching a natural phenomenon push to its physical limits? Or was this acceleration, this brightening, this refusal to disintegrate, caused by something else, something internal, something controlled, something we do not yet have a language for? From this point forward, the data will only get stranger. Brightness, color, trajectory, even rotation. Each one a thread in a larger pattern. And that pattern has already begun to split from the script we wrote for the stars. The moment it broke the curve, our old models were no longer enough. There's a principle in celestial mechanics so deeply woven into our understanding of the universe that we rarely question it. Objects in space move according to gravity. The tug of the sun, the pull of planets, the slow dance of mass and distance, predictable, measurable, knowable. But sometimes an object refuses to obey, and that is where the term non-gravitational acceleration enters the conversation. In simple terms, non-gravitational acceleration refers to movement that cannot be explained by gravity alone. a change in speed or direction that doesn't match the calculable effect of known forces. Something else is acting. Something outside the equation. For comets, this is sometimes caused by outgassing, a process where ice beneath the surface turns into vapor, creating jets that push the object ever so slightly off course. A kind of cosmic thruster. We've seen that before, and we've built models for it. But what we are seeing with 3i Atlas is not a familiar outgassing signature. It is smoother, stronger, more continuous, as if the force at work is not a random burst, but a sustained push, not a leak, but a drive. Imagine a car set on cruise control, locked at a steady 100 kilometers per hour. The road levels out. There's no hill, no wind pushing from behind, no driver's foot on the pedal. But suddenly the speedometer ticks up. 101, 103, 105. Nothing external is visible. Nothing mechanical is changing in front of you. And yet the car is clearly accelerating. In physics, that should not happen. And yet, that is precisely what 3i Atlas is doing. The object is moving faster than the sum of gravitational forces acting upon it. Not in a burst, not as a brief spike, but in a persistent trend. A trend confirmed by optical data, radar tracking, infrared telemetry, and the calculations of observatories from 3 continents. No collision, no gravitational slingshot, no nearby source of mass or energy. Just acceleration, with no one touching the gas. The crucial distinction here is that we are not guessing. No one is shouting alien spacecraft or artificial propulsion without evidence. But the evidence we do have leaves a gap. There's a force acting, and we don't yet know what it is. Is it natural? Possibly. A new type of sublimation? An internal thermal reaction? A spin-induced pressure release? Or is it something truly new? Brian Cox once said, "The universe is simple, beautiful, and it's governed by deep underlying principles. But when an object begins to move in ways that violate those principles, we are faced with only 2 options: expand the principle, or admit that we never fully understood it. Either way, 3i Atlas just forced our hand. And from here, the investigation will turn to the next clue. Not just how fast it is moving, but why it is shining. And why it is shining the wrong color. One of the first things astronomy teaches us is that brightness tells a story. Comets don't just glow, they evolve in light. They brighten as they approach the sun, peak near perihelion, then fade as their energy source recedes. It is a rhythm we have observed for centuries, a choreography between ice, dust, distance, and heat. But 3i Atlas is not following the choreography. Instead of brightening as expected, it brightened too early, too strongly, and in a way that does not align with any standard model of cometary outgassing. If brightness were a voice, this one is speaking out of turn. When plotted on a graph, a simple light curve over time, the result is as unsettling as it is undeniable. The peak of 3i Atlas's brightness arrived earlier than it should have. The graph, which should resemble a clean, smooth rise and fall around perihelion, looks as if someone reached in and dragged the curve upward before its time, like a restless wave, or a signal out of sync. No debris tail large enough to justify the jump, no violent fragmentation visible in the coma, no sudden increase in dust scatter, just an object that, for reasons not yet understood, refused to follow the brightness schedule that every physics textbook says it should. To put it simply, the graph did not obey. This is not a poetic metaphor. This is data, captured in time, filtered through calibrated instruments, verified by multiple observatories. A brightening phase that began days earlier than predicted, followed by a plateau stronger than typical reflective scattering can explain. And then there is the spectrum. Normally, when a comet brightens, a large percentage of that light comes from sunlight reflecting off dust grains released by sublimating ice. The color trends warm, reds, yellows, amber tones. But 3i Atlas brightened without the dust. The spectral lines showed a dominance in the blue range, close to the wavelengths associated with ionized gases like CO+ or C2. But even then, with a profile that's just slightly wrong, like a voice trying to mimic a song in a familiar key, but missing a note no human ear was meant to ignore. A comet that glows too early, too strongly, with the wrong color, and with a spectral composition that falls just short of its nearest known match. It's not just strange, it's mathematically disobedient. In astronomy, brightness is rarely a mystery. It is usually an equation, energy in, light out. But here the math does not close. If the object is brightening because it is shedding mass, where's the particulate signature? If it is glowing due to high energy ionization, what is the source of that energy? If it is coasting on sunlight, why does its reflective output not fade with distance the way it should? The light curve has become, in itself, a kind of witness, a ciphertext etched into photons. And the message it carries is this: 3i Atlas is being powered by an energy source we cannot yet account for. Whether that source is buried within its structure or acting upon it from the outside, we do not know. Whether it is a process we've never observed or a mechanism we've never imagined, we cannot yet say. All we know is this: the brightness arrived ahead of schedule. The peak came early. The glow stayed strong. And the comet refused, as if on principle, to dim in the way every other object in its class eventually does. Next, we follow the color. Because brightness is one question, but blue is another. The color of a comet is not random, it's a message. One written in photons, decoded by spectra, and rooted in chemistry. When we look at a comet and see it glow in shades of red, gold, or faint yellow, we're not just seeing light, we're seeing dust, tiny grains of silicate and carbon reflecting sunlight back to us. That's the signature of almost every comet humanity has ever cataloged. But 3i Atlas is not dust red, not ember yellow, it is blue, not a hint, not a gradient. Right now is a clear, measurable blue, a wavelength that should only dominate when gases, not solids, are being energized. And that, on its own, would be strange, but explainable. We know, for example, that ionized carbon monoxide, CO+, and a diatomic carbon, C2, can emit a brilliant blue glow under the right conditions. Some comets do show a mild blue halo in their ion tails, but here's the first problem. 3i Atlas is not showing a blue tail, it's showing a blue coma. The entire thing. The glow isn't trailing behind it, it's wrapped around it. Like the whole object has been bathed in an invisible energy that is driving it from the surface out. That is not how a typical comet emits blue. And here comes the second problem, the deeper one. When you look closer at the spectral analysis, 3i Atlas doesn't match CO+ or C2 perfectly. It matches almost, like a fingerprint that is one line off from any known database. The peaks in its light signature are close enough to resemble high volatility ionization, but they don't line up precisely. One line is shifted, one frequency is too shallow. The ratios are just wrong. It's like hearing a familiar song played on an instrument slightly out of tune, a melody you recognize, but with a note that shouldn't be there. A comet should redden as it sheds dust. 3i Atlas has done the opposite. It has shed dust and become bluer than the sun in some wavelengths. And even if we try to force-fit the known explanations, ice sublimation, volatile release, solar activation, the spectrum keeps resisting the model, like a gear turning one tooth out of sync. That almost is what's keeping astronomers awake at night. Because in science, the gap between almost fits and fully fits is where the truth hides. And a truth that sits in that gap is always uncomfortable. If the blue glow is coming from ionization, what is powering it? If the signature resembles carbon-based volatiles, what is skewing the ratio? If the coma shows no dust, where's the material going? Everything we know about comet chemistry tells us that blue is the exception. Yet here it is, the dominant color. As Brian Cox once said, science is about finding things out. It is not about proving something is right. And right now, the blue of 3i Atlas isn't proving anything. It's raising the question that sits beneath all science. What are we missing? 3i Atlas is playing a familiar rhythm with one discordant note, a note sharp enough to break the harmony, a shade of blue that shouldn't exist, or shouldn't exist this way. That's why astronomers aren't satisfied, not because it's dramatic, but because it doesn't fit. From October 29th to October 31st, 2025, the world stood in a kind of astronomical blackout, as 3i Atlas passed behind the sun from Earth's perspective. Every optical telescope on the planet went blind to it. No ground-based observatory could track it. No visible light camera could pierce the glare. For 3 days, the object vanished. Imagine a vehicle speeding through a monitored highway, every camera capturing every frame, until suddenly, it turns into a tunnel. The lights stay on, the road continues, but the cameras go dark. You don't know what's happening inside. You only know that when it comes out the other end, either it's the same or something has changed. That is what those 3 days meant for 3i Atlas. The optical spectrum, our primary window into the cosmos, became useless. The sun's brilliance swallowed every trace. It wasn't that 3i Atlas wasn't there, it was that we could no longer see it. A 300,000 kilometer wide wall of light stood between us and an interstellar object behaving outside the lines. And in that darkness, something happened. What we had instead, during that blackout, were only 3 thin threads of data: ultraviolet, X-ray, and radio, like faint signals bleeding through static. NASA's Swift UVOT recorded weak increases in OH emission lines, suggesting water molecules were being stripped apart by solar radiation. ESA's JUICE spacecraft, positioned away from the worst of the glare, logged slight fluctuations in the object's rotational period, too small to confirm, but enough to raise the question of whether the object was interacting with thermal stress or internal forces. And then there were the radio pings, barely above noise floor, picked up by deep sky arrays in California and South Africa. Not signals, not information, just energy flickers. The kind consistent with high-velocity ionized material moving through solar plasma. Nothing conclusive, everything suggestive. For 72 hours, the world's greatest instruments stared at the sun and waited. There was no image to align, no comet to trace, only a blank frame with a blinding center and a silence full of implied motion. Because this wasn't just a blackout, it was a narrative gap. Something crossed between what we knew before the sun and what we saw after. When 3i Atlas reappeared on November 1st, it was different, faster, bluer, and still intact. What went in red and dusty came out blue and gleaming. What went in as a question mark came out as a problem. And so the mystery deepens not in what we saw, but in what we couldn't. We don't know what happened in the tunnel, only that the cameras were off. And when they came back on, something wasn't the same. Astronomy isn't used to blind spots. The universe tends to be kind enough to display its workings. But once in a while, it writes a chapter in the dark and challenges us to fill in the blanks. That is what the 29th to 31st of October represents. Not just an observational gap, but a physical turning point that the data, even now, can only point toward. Through the silence, one question remains. Whatever changed back there? Was it the comet or our understanding? When 3i Atlas emerged from behind the sun on November 1st, 2025, the world's telescopes turned toward it with a familiar expectation, to pick up where they left off, to see a typical post-perihelion object, dimmed, reddened, perhaps fragmented after enduring the sun's heat. That is what the script said should happen. Instead, the first images that came in were not a continuation. They were a contradiction. On October 31st, just as sunlight began to fade enough for optical instruments to recover, Chichang Zhang at the Lowell Observatory in Arizona captured the first resolvable image of 3i Atlas after its 3-day disappearance. The photo showed what no astronomer wanted to see, but every one of them needed to accept. It was still blue. It was still bright. And its coma was no longer symmetrical. This wasn't just a comet that had survived perihelion. This was a comet that had changed during it, and come back with its anomalies intensified. Zoom into the image, and you see it. The familiar circular haze of a typical coma is uneven. One side stretched outward, feathered into a strange, plume-like distortion, as if something was pushing material preferentially from one direction. Not the diffuse dust drift of a melting nucleus, but a directed pattern. A biased release, the kind of feature that makes the mind reach instinctively for words like venting or thrust. It's there in the data. The brightness hasn't collapsed, the spectrum hasn't warmed, the coma hasn't stabilized. What went into the solar glare in late October was anomalous. What came out of it in early November is even more so. This is not the return of a comet tiring in its arc through space. This is the escalation of the unknown. More images followed from South America and Europe. Every one of them confirmed the same strange triad: color, blue, brightness, rising or sustained, structure, asymmetric. It was as if nothing about the sun's proximity had weakened it, as if the perihelion had not depleted it, but activated something. The deeper you look, the more the questions stack. Why isn't the brightness curve collapsing? Why hasn't the coma red shifted? What force is shaping the asymmetry? If this is outgassing, why isn't the spectral ratio matching? If this is fragmentation, where are the breakaway pieces? If this is natural, Why does it look orchestrated? Every new image is a revelation and an opening. For every answer it offers, it births two new questions, like a puzzle where each piece added makes the picture less clear, like an echo that grows louder the further it travels. 3i Atlas didn't just reappear, it reasserted its strangeness, stronger, sharper, more defiant. And now, with every frame, every spectrum, every shift in its coma, we are forced to accept a simple, inexorable truth. The more we look, the less we understand. In the world of science, especially at the scale of NASA's operations, anomalies are not treated as curiosities. They are treated as threats to the data, to the models, to the credibility of the field itself, which is why NASA almost never raises a flag unless the evidence leaves them no responsible alternative. And with 3i Atlas, NASA has raised one, not because of a hunch, not because of a single glitching telescope, but because, after multiple rounds of checking, cross-checking, and attempts to explain the numbers away, the data refused to obey. The deviations persisted. It wasn't atmospheric interference, it wasn't sensor drift, it wasn't a rounding error in software, it wasn't a calibration issue. Every possibility that could be dismissed was. And when the smoke cleared, the anomaly was still there. When NASA publishes an internal consistency note, it reflects a process not of speculation, but elimination. Teams running parallel systems with different instruments and different bandwidths, under different conditions, tasked with a single job, to prove that the anomaly is not real. But this one held. Orbital mechanics, checked. Photometric calibration, checked. Instrument drift logs, checked. Error, normalization across facilities, checked. And after every red line was tested, every margin accounted for. The numbers still bent where they shouldn't. As one mission analyst phrased it, not publicly but in a technical debrief, we ran the math in circles and the deviation stayed still. That is what triggers a flag, not the anomaly itself, but the failure of every standard explanation to eliminate it. And this matters. It matters because NASA is not in the business of endorsing the unknown. It is in the business of understanding it. When they use terms like non-gravitational acceleration in official updates, they're not being dramatic. They're being clinical, precise. They're speaking a language that leaves room only for what the data will support. And the data, at this point, support exactly one thing. Something other than gravity is acting on 3i Atlas. Not a belief, not a hypothesis, a measurement. NASA's tone remains cautious, reserved, academic. Not because the anomaly is small, but because restraint is the only responsible posture when the familiar breaks. To flag is not to proclaim revelation. It is to acknowledge that the model is no longer holding. And that is how a mystery becomes official. From November 4th to December 19th, 2025, we are inside what may one day be called the most important 45-day window in the study of interstellar objects, a period in which 3i Atlas is close enough, bright enough, and active enough for continuous observation. A window we will not get back once it fades into the deep background of space. This is not just a scientist's opportunity, it is a public one. Unlike the missions that take place behind the sealed doors of laboratories and control rooms, this investigation invites participation, not symbolic involvement, not passive interest, but real contributive observation. Because the truth is this: no single institution has the full sky, but all of us together do. Every like, every comment, every subscription here is not just a token of support, it is a signal, a data point, that you are following this investigation with intent, that you are choosing to see rather than to scroll past. When enough people choose to see, a network begins to form. And when that network aligns around the sky, it becomes more than passive interest. It becomes a platform of coordinated attention. So if you're watching this, not just as a viewer, but as a witness, I'm asking you to do one thing. Write in the comments where you're watching from. City, country, hemisphere. It's not for vanity. It's for mapping. To find out where eyes are on the sky. If you're someone with access to equipment, even a moderate telescope under dark skies, you could become part of the effort to track the only interstellar object currently undergoing verified anomalous behavior. If you're not, you can still amplify, still signal, still stand among those who took the moment seriously. Because this isn't a celebrity event. This isn't a trending topic. This is a countdown, and we are already inside it. 45 days is the limit. Past December 19th, 3I, Atlas will begin to dim, slip away from Earth's vantage point, and vanish into the long freeze between stars. What we learn now, or fail to learn, will define the next decade of research on interstellar phenomena, and whether we miss something historic or capture it in time depends not only on institutions, but on communities, on people like you. Science is not a wall, it is a field, and every observation is a seed. So let's mark this window together, November 4th to December 19th. Track, watch, share, not for hype, for history. And remember, even a simple gesture like adding your location below is more than interaction. It becomes a coordinate in a global constellation of awareness. The sky is speaking. The question is, who's listening? In all the centuries humanity has spent watching the sky, we have confirmed only 3 objects that came to us from another star system. Not fragments of our own past, not leftovers from our own solar debris, but true visitors, formed under a different sun, born in a different stellar nursery, shaped by forces we've never seen up close. The first was discovered in 2017, Oumuamua. The second followed in 2019, 2I Borisov. The third is 3I Atlas. 3 objects. That is all. Not 3 a year, not 3 a century. 3 in the entire scientific history of humankind. You are living in the age when the universe finally started answering back. And not with theory, with presence. Oumuamua was a shock to the system. A cigar-shaped object with no coma, no dust, no visible tail, yet accelerating as if pushed by an invisible force. It was the first time we realized that something could enter our solar system, behave unlike anything we'd seen, and leave just as quietly, without waiting for our explanations to catch up. 2 years later came 2I Borisov, a far more normal interstellar visitor, with a visible coma, a classic dust tail, and a composition that matched our textbook comets. A relief almost, a reminder that the strange could also be familiar. And then, in 2025, came 3I Atlas, the third page in a book that may one day define a new era of astronomy. But here's the crucial thing. 3I Atlas is not like either of its predecessors. It is not dustless and silent, like Oumuamua. It is not dust-rich and stable, like Borisov. It is something else, with the brightness of a comet, the acceleration of something unbound, and the spectral fingerprint of a process just beyond the edge of what we can model. The first interstellar object raised questions we couldn't answer. The second seemed to soothe our uncertainty. The third has reopened every door. There is a feeling, one shared quietly by those who work in this field, that we are no longer studying cosmic accidents. We are studying a category, and every time a new visitor appears, the category gets messier, more layered, more alive. 3 pages into the interstellar record, and nothing matches perfectly. Not orbit, not brightness, not chemistry, not behavior. If these are the first 3 chapters of a book the universe has only just begun to write, then we are not closing in on an answer. We are stepping into a field of questions. To watch 3I Atlas now is not simply to watch a moving object. It is to stand in the middle of a living archive, one that will be read and reread long after this comet has vanished. Astronomers used to dream of seeing the first interstellar object. You are alive to see the third. And the third has come not to repeat, but to disrupt. The story of 3I Atlas didn't begin with its dramatic reappearance in early November, or even with its close brush past the sun. The trail of anomaly started earlier, quietly, almost politely, as if the object were testing the edge of our awareness. It began on October 15th. On that date, the first deviation appeared, a brightness drift, just half a magnitude at first, something that could easily be written off as a calibration quirk or a trick of atmospheric conditions. But it held, and instead of returning to the expected curve, the brightness continued to rise, edging upward like a plotline, unaware it had entered the wrong graph. 5 days later, on October 24th, came the second red flag, an acceleration drift. The velocity reading didn't match the model, not dramatically, but definitively. An adjustment was made, then another, and another, but the discrepancy remained. Small, subtle, persistent, the celestial equivalent of a heartbeat skipping its rhythm. It might have been ignored if it stopped there, but it didn't. From October 15th to October 29th, the plot points began to climb, not with chaos, but with progression, as if each observed irregularity was not a random event, but a chapter in a sequence. Brightness deviation, October 15th, acceleration deviation, October 20th. Spectral shift begins, October 25th. Perihelion event, October 29th. Trajectory deviation sustained, October 30th onward. That is the mini timeline. 1 week, 2 anomalies. 2 weeks, 3. By perihelion, it wasn't a crack in the model anymore. It was a trend line. This is not how comets behave. This is how stories unfold. The graph didn't jolt, it climbed. Each deviation wasn't a burst, but a layer, building toward a threshold. A comet doesn't plan its behavior, but the data looked planned, measured, almost choreographed. Even the temperature curve shifted. Even the predicted outgassing profile sagged away from the expected thermal response. One by one, the pieces of the model began to lean away from the center, not far enough to fall, but far enough to tip the balance of certainty. And that's the strange beauty of it. Nothing was explosive. Everything was incremental, like a string pulled tighter 1 millimeter at a time, until the snap wasn't a surprise. Only the timing was. What started as a blip in mid-October became a pattern by the end of the month, and by November that pattern became a problem, which leaves us with a question bigger than the deviations themselves. Was this a chain reaction of natural events? Or was this a sequence, a process already in motion long before we noticed it? Either way, the graph has climbed out of the textbook, and it isn't coming back down. Tracking a fast-moving object near the sun is not just a scientific challenge, it's a technical hazard. When 3I Atlas entered its perihelion phase, it didn't just slip behind the sun from Earth's perspective. It also crossed into what astronomers sometimes refer to, in quiet understatement, as the danger window. Imagine this. Extend your arm fully in front of you, make a fist, then another, then one more. Those 3 fists edge to edge, roughly 30 degrees, represent the angular distance from the sun where most optical instruments risk being overwhelmed by solar glare. That's the area 3I Atlas passed through in late October, a zone where even the best telescopes hesitate. Not because they can't point there, but because the risk is real. Point too close, and your sensor isn't just flooded with noise. It can literally burn out. Optical detectors, CCD, CMOS, or even high-grade adaptive optics are built to operate within safe photon loads. The sun doesn't just exceed that limit, it obliterates it. A single miscalibration or mistimed exposure can fry an instrument worth hundreds of thousands of dollars. That risk doesn't just make astronomers nervous, it makes them cautious. So when we say optically blind from October 29th to 31st, it isn't a metaphor. It's physics, it's geometry, it's survival. The telescope doesn't care if the anomaly is historic. It cares whether its cooling unit and detector array can withstand 136,000 lux of solar radiation spilling across its aperture. Even satellite-borne instruments aren't immune. The continent-spanning dishes and deep space observatories have to obey the same law. The sun is a sensor killer. And when an object crosses too close, the choice isn't between data and no data. It's between saving the instrument or losing it permanently. Which means this phase around perihelion wasn't just a scientific blackout. It was an enforced one. All we had during that window were blind approximations, ultraviolet and X-ray glimpses, radio echoes, none of them sharp, all of them strained through the noise of solar interference. The proximity wasn't just inconvenient, it made seeing impossible and risking irresponsible. So when 3I Atlas reappeared intact, bright, accelerating, it didn't just defy physics, it outran the limits of our ability to watch. That's the reality of tracking something near the sun. Not mystery, not mythology, just harsh, blinding sunlight, and the fragile eyes of our machines. When the optical world went dark during 3I Atlas's passage behind the sun, astronomy turned to its other senses. If the visible spectrum was off limits, then the investigation would move into wavelengths the sun couldn't drown: ultraviolet, X-ray, and radio. This is where our story stops being about what we can see and becomes about what we can infer. NASA's Swift Observatory was the first to pick up a trail. Operating in the UV and X-ray bands, Swift is immune to the kind of glare that blinds traditional telescopes. And during the critical 72-hour blackout, Swift's UVRT detected faint but meaningful increases in OH emission lines, the chemical signature of water molecules being broken apart by solar radiation. Water, not ice, not dust, not debris, reaction. In comets, OH is a secondary product, a child born of destruction. It forms when solar photons slam into H2O vapor, breaking the bonds and leaving behind radicalized fragments that emit an ultraviolet. Which means, in those 3 days, while the visible sky was silent, something inside 3I Atlas was actively releasing water vapor into space. Not enough to fracture, not enough to dim, just enough to betray activity at the molecular level, without giving us the shape or cause. While Swift probed in UV, the JUICE spacecraft, millions of kilometers away, watched from yet another angle. Designed primarily for future studies of Jupiter's moons, JUICE had the advantage of a viewing perspective free from the sun's direct interference. Its instruments detected subtle fluctuations in the object's rotation period and mid-infrared scattering, suggesting not only that 3I Atlas was spinning, but that its spin may have shifted, however slightly. One observatory, one wavelength, one angle would not have been enough, but combining Swift's OH data with JUICE's rotation and scattering logs gave rise to an unsettling possibility. 3I Atlas did not simply survive perihelion, it responded to it, not like a passive block of ice and dust, but like a system with internal processes triggered by proximity to heat and radiation. One layer gives us water vapor, another layer, rotational change, another, asymmetric scattering of emitted light. Each layer, on its own, is ambiguous. Together, they begin to form a picture. Astronomy is often described as the study of light, but here it is better described as the study of fragments. UV on one side, infrared on the other, radio peeking through the noise, each one a piece of a puzzle that refuses to sit still. In the absence of direct sight, we built an image from the wavelengths the sun couldn't smother. Not one powerful telescope, but a network of partial truths, a string of ultraviolet snapshots, a handful of X-ray traces, and the quiet telemetry of a spacecraft that caught a glimpse from the corner of its mission. And the object begins to speak again, not in visible light, but in the spectrum of survival. Science is built on matching patterns. We observe, we compare, we model, and when the data aligns with expectation, we call it understanding. But with 3I Atlas, understanding has become a game of approximation, because every major trait of this object, brightness, acceleration, color, fits just close enough to seem familiar, but not close enough to resolve. Brightness, almost that of an active comet. Acceleration, almost explainable by outgassing. Color, almost matching ionized carbon signatures. Almost, almost, almost. But when the third almost meets the first two, the pattern breaks. It's like trying to assemble a puzzle where every piece is technically the right shape, but doesn't quite lock. You press it in anyway, force it, step back, and the picture's wrong. The edges warp, the sky stretches where it shouldn't. The mountain bends at an impossible angle. You have all the colors, you see the outline, but the image has gone uncanny. That is 3I Atlas, brightness like a comet, but without the expected dust trail, acceleration like a pressure jet, but without the volatile signatures to match. A blue coma like CO+ ionization, but with spectral lines shifted just enough to deny certainty. Individually, each anomaly might be excused as a fluke. Taken together, they form a mosaic of error. Not error in measurement, error in assumption. It's as if nature is speaking a dialect we almost understand. The sentences are structured, the words recognizable. But the inflection, the emphasis, the meaning, slides just outside comprehension. Astronomers are trained to distrust the edge cases, to assume that if something is close enough, it will settle into place with better data. But here, the better data has only made the almost sharper. What once looked like the tail of a comet now looks like an asymmetrical emission. What sounded like basic rotational drift now hints at torque. What appeared to be a color shift now resists the template of CO, C2, or any known volatile cocktail. Nothing is dramatically incorrect. Everything is imperceptibly off. And that is sometimes worse than open contradiction, because contradiction can be exposed, but inconsistency corrodes silently. You could try to force fit it all into a natural model, but the more you do, the more the model fractures. As one spectroscopist put it, if this is a puzzle, the pieces were cut by someone who never saw the box art. Even the term comet is beginning to feel provisional, because what do we call something that walks like one, shines like one, and moves like something else entirely? This is the uncanny valley of astrophysics. We recognize the form, but not the intent. The data forms a shape, but the shape is crooked, and until it straightens, the name we're giving it is not a classification. It's a placeholder. We're not missing a piece. We're missing the space between them. When science encounters the unfamiliar, the first responsibility is not to leap into the extraordinary, but to exhaust the ordinary. Whatever 3U Atlas is, however strange its behavior may appear, we must begin where scientific discipline demands. By assuming nature is not hiding any secrets, we are simply missing some parameters. And so, before we allow ourselves to drift into the seductive orbit of speculation, we take up Occam's razor, not because it guarantees the truth, but because it is the most stable place to start the pursuit. There are, at present, 3 leading natural hypotheses that attempt to explain the behavior of 3I Atlas using only adjustments to known processes, without invoking exotic physics, technology, or intent. None of them is perfect, all of them are incomplete, but each is a legitimate attempt to bend the model rather than break it. Let us examine them in turn. We have ne'er but one, a gas-rich, dust-poor comet with enhanced outgassing. In the simplest version of the comet model, 3I Atlas is not so much a mystery as a miscalibration. What if it is simply a comet with unusual composition? Less dust, more gas, higher volatility at lower temperatures. If that were the case, several of the anomalies begin to slide into place. A dust-poor comet could survive perihelion with little visible fragmentation. A gas-rich one could brighten without shedding the heavy silicate materials that would normally create a yellow-red coma. The blue glow could be the result of strong ionization of carbon monoxide, CO, or diatomic carbon, C2, released in greater concentration than usual. Meanwhile, the non-gravitational acceleration could be explained not by propulsion, but by natural thrust, a high rate of sublimation acting like a jet. Under this model, 3I Atlas is not breaking the rules. It is stretching them by exaggerating one property, volatility. In simple terms, shrink the nucleus, raise the gas content, activate it earlier, and the physics shifts. Like turning a dial on a machine, smaller, lighter, more evaporative. Suddenly, a strange object becomes just a thermally efficient one. Like a puddle on hot metal, it doesn't just evaporate, it jumps. In this scenario, everything could technically fit. The brightness, the acceleration, the blue emission, even the odd coma shape. But even this model fails to explain the precision of the acceleration trend, or the near-perfect sustainability of the brightness. Gas jets are messy. Outgassing is irregular. The behavior of 3I Atlas is not. It's close. It's sensible. But it's not yet enough. Taikin 2. Internal heating via radioactive or chemical instability. Another hypothesis steps deeper into the composition of the object itself. What if 3I Atlas carries not just high volatility ices, but internal heat sources, like radioactive isotopes or reactive chemical stores that are only triggered at certain temperatures or energies? This idea follows the logic of moons like Europa or Enceladus, where internal heating allows for subsurface activity independent of sunlight. Now scale that down. Imagine an object the size of a small mountain, seeded with a few grams of unstable isotopes. As it nears the sun, its interior compounds shift phase, crack, and react. Not explosively, but consistently. Such a process could generate thermal pressure from within, powering asymmetric gas release, rotation shifts, or anomalous acceleration. The blue emission could be a byproduct of chemical excitation rather than solar ionization alone. Unlike the gas-rich model, this one explains timing better. The closer 3IR Atlas gets to the sun, the more its internal generator kicks in. What looks like behavior is really stored energy reaching activation threshold, like a frozen battery thawing out, not alive, just responsive. But again, the data pushes back. Internal heating is chaotic. Particles break off. Structures fail. Internal energy does not typically result in symmetry, but in fracture. If this process were dominant, we would expect debris clouds, rotational wobble, or cooling irregularities. So far, we see only coherence, not decay. Close, again, but not close enough. The 3. Structural break or surface venting causing controlled jets. The third hypothesis suggests that 3I Atlas did fragment but not in a catastrophic way. Instead, structural stress from perihelion or internal gas pressure may have opened an internal vent or crack that is now acting like a permanent jet, a one-sided thruster. That would neatly explain the asymmetric coma, the smooth acceleration, and even the brightness. The same jet could be pushing the object and ejecting ionizable material. The idea here is not high drama, just fracture physics. Ice expands, cracks split, gas escapes, and the object slowly stabilizes into a new behavior mode. Even the blue glow could fit this framework. Fresh interior material exposed to sunlight for the first time. Darker ices replaced by purer volatiles. But once again, this comes at a cost. This model requires a very unlikely combination of geometry and structural integrity. Breaks in comets are rarely stable. Vents collapse. Spin rates destabilize. Material disperses. Nothing we've observed so far supports long-term vent behavior over violent decay. A jet that lasts too long stops being a vent and starts looking like a mechanism. Frozen, here then, is the real point. Each one of these 3 hypotheses brings us close enough to feel intellectually safe. Enough to say, well, yes, if we twist this assumption a bit, if we nudge this parameter, if we rotate this dial, maybe it all works. But science is not the art of forcing pieces to fit. It is the discipline of refusing to lie to the model. In trying to solve 3I Atlas, naturally, we are discovering not a neat solution, but a lingering discomfort. Everything is almost explainable, but nothing is fully. Every guess edges us back toward normal, but the shape of the anomaly remains, like a mirror that reflects 90% of the image and smears the rest. So we begin here, with the humble tools of what we already know. And if they prove insufficient, then we climb, not into fantasy, but into the possibility that the universe has brought us something beyond adjustment. Until then, we turn the dials one by one. Small nucleus, high volatility, internal heat, asymmetric jets, everything natural, everything plausible, everything incomplete. And so the razor remains sharp, but its cut no longer reaches the core. If nature is the author of 3I Atlas, then one of the most intriguing explanations for its behavior lies not on its surface, but beneath it, within its core, its chemistry, and its temperature. The second major hypothesis for 3I Atlas's anomalies proposes that internal heat, generated either through radioactive decay or chemical reactions, may be driving the object's unexpected brightness, acceleration, and emission signature. This is the thermal engine hypothesis, not based on fantasy, but on examples already present in our own solar system. To understand it, we need only to look toward the outer planets. Tag the model, frozen objects that run warm. We have 4 examples right here in the solar system of frozen celestial bodies that are not as inert as they appear. Europa, a moon of Jupiter, hosts an ocean beneath its icy shell, kept fluid by tidal heating and possible radioactive decay. Enceladus, a moon of Saturn, vents plumes of water hundreds of kilometers into space, driven by internal heat spiraling through its fractured crust. Even the dwarf planet Ceres shows signs of cryovolcanic activity, possibly powered by radiogenic elements trapped in ancient ice. In each case, an object that looks cold, dead, and geologically simple from the outside is revealed to be thermally active inside, with heat generated either mechanically or radioactively, building pressure over millennia until it finds an escape path. What if 3I Atlas is a smaller, more volatile version of this pattern? Not a moon, not a planet, but an object with just enough internal energy to become reactive under solar influence. Picture this: 3I Atlas spends millions of years drifting through interstellar space, its interior cold and quiet, every reaction slowed almost to a stop. Then, without warning, it enters a solar system, falls toward a star and its interior begins to wake. Atoms rearrange, chemicals destabilize, frozen volatiles begin to move. The internal pressure rises. At first, nothing happens. Then the perihelion comes, and the trigger point is reached. The gases release, the brightness spikes, the acceleration begins. Not because the object is breaking, but because something inside it is finally alive enough to push outward. The ingredients: radioactivity and reactive ice. Two internal mechanisms could power this scenario. 1. Radioactive decay. Some isotopes, like aluminum-26, potassium-40, or long-lived uranium derivatives, can generate heat through gradual decay. Not enough to melt rock, but enough over time to build thermal gradients within a smaller body. If 3I Atlas contains even trace amounts of such material, buried beneath layers of frozen volatiles, this could create internal warming, especially during solar heating events. When the object nears the sun, the combination of external radiation and internal decay might lead to a nonlinear release of gas, pressure, and rotation, explaining the smooth, persistent acceleration and asymmetric coma. 2. Chemical reactions in deep ice. Certain ices, especially those that contain trapped gases, organics, or unstable compounds, can undergo exothermic reactions when warmed. These are reactions that produce heat as they occur. Think of it like a chemical fire in slow motion. The logic here is familiar. Comets are not just ice, they are mixtures: water, methane, ammonia, carbon monoxide, even formaldehyde. If these pockets thaw unevenly, or if sublimation exposes previously sealed layers, we might see sustained, directional gas release that behaves like a jet, but is not explosive. A controlled burn of chemistry, not a detonation. Either mechanism, or some hybrid of both, could lead to a sustained internal pressure system that vents just enough material to keep the object accelerating and glowing without fragmenting it. That's what scientists find seductive about this hypothesis. It preserves natural law. It requires no external actors, no hidden engines, just chemistry under the right and rare conditions. So are we where it matches the data and where it breaks. There's a reason the internal heating theory remains one of the leading conservative options. It aligns neatly with several of the key observations. Smooth non-gravitational acceleration? Check. Controlled outgassing could do that. Asymmetric coma? Check. A single sustained vent could cause uneven material flow. Blue spectral profile? Possibly. Ionized volatiles from deep ice or exotic deposits could emit in the blue range. No major fragmentation? Yes. Pressure relieved gradually, not explosively. But, as always with 3I Atlas, the theory does not resolve everything. The main issues are spectral mismatch. The emission lines still don't align fully with known volatile mixes. They drift, like a halfway match. Brightness curve smoothness. Outgassing from heat or chemistry tends to fluctuate. But this brightness curve is stable, too stable. Acceleration precision. Even in cryovolcanic bodies, thrust is messy. But here, the push is measured, almost linear. It's like seeing the fingerprints of a known process, but blurred by a pattern no one expected. As one planetary chemist put it, if it's chemistry, it's a chemistry we've never sampled. The temptation of the middle road. There's also a psychological allure here, and it's worth admitting. Of all the natural explanations, this one is the most comforting. It gives us an answer we can live with. Yes, it's strange. Yes, it's unusual, but it's just nature being surprising. We swap the mystery for a tweak in the model. Add radioactive ice here. Turn up the subsurface temperature there. Now this alien object slides into the category of extreme comet, not possible artifact. The mind rests easier on that shelf, but the question remains. Does the data rest there too? The verdict, for now, internal heating is not being dismissed. It is not fringe. It is still being tested, in simulations, in spectral breakdowns, in peer-reviewed drafts making their way through preprint servers. But as of now, it is not sufficient. Like every other normal first hypothesis, it runs into the same wall. It explains almost everything, and almost everything is not everything. Until the anomalies shrink, or the data spikes, this explanation hovers not as truth, but as one of the best shadows of it. Or, as a comet physicist recently put it fits on paper, but not in reality. So we keep it, we refine it, but we don't stop there, because whatever's inside 3i Atlas isn't done speaking yet. If 3i Atlas is not being driven by internal reactions alone, and not simply outgassing more efficiently than usual, then the next most plausible natural explanation is also the most instinctively dramatic one. It broke, not exploded, not dissolved, but fractured, cracked open under heat and spin, exposed a deeper layer, and in doing so, transformed. This is the fragmentation scenario, the idea that 3i Atlas has undergone a structural break, or surface cleave that peeled back its outer layers, exposing volatile materials deeper within, triggering a cascade of secondary effects we now observe as anomalous. On paper, it's simple. Heat plus spin plus low tensile strength, tasses rupture, dust shell breaks, gas-rich interior vents, sudden brightening, boosted acceleration, altered spectral signature. A chain reaction, all natural. No mystery, just physics in overdrive. But to understand how this would work in the real cosmos, we need to break it down event by event. Bishad Barwa, Stage 1, Tidal Strain and Thermal Stress. As 3i Atlas approached perihelion, it entered a zone of rapid thermal change. Parts of its surface would have been exposed to intense solar heat, while others lagged, insulated by shadow or poor conductivity. That creates thermal stress, internal expansion and contraction that can crack rock, ice, and composite bodies alike. Simultaneously, its rotation, measured to be both rapid and possibly increasing, introduced centrifugal stress. Spin something fast enough, with the right balance of mass and structural weakness, and it doesn't need to hit anything to start coming apart. It shreds itself. The combination of these two forces, thermal stress and rotational torsion, is a well-known comet killer. We've seen comets split in two this way. We've watched tails kink, nuclei shatter, and light curves spike as internal pressure is violently released. So far, nothing here breaks the laws of nature. Until we get to what happens next. Stage 2. Surface fracture and core exposure. If the crust of 3i Atlas cracked, even in a controlled or partial way, it could expose a layer of material that has never interacted with space before. Ancient ices, trapped gases, primitive volatiles from its formation beyond another star. The result of such exposure, a cascading vent event. Not an explosion, but a release. A jet or spray of pressurized gas and ice crystals erupting from the opening, pushing the object in the opposite direction. Newton again, quietly doing its job, while also releasing fresh, unweathered material into the coma. And that coma, already unusual, becomes a stage lit from the inside. Think of it like cracking a geode. It looks rugged from the outside, and then it splits and reveals a core of shimmering blue crystal, untouched by time. Except here, the geode is moving at 68 kilometers per second, and the crystals are molecules turning to plasma. That would explain the brightness spike. The asymmetric coma, the faint condensation-like knots appearing in the exposed material. Even the ion blue, if the gases released were heavily carbon-based or contained substances shock-sensitized to trace radiation. You can almost imagine it. A shell gives way, a vent forms, the comet doesn't die, it becomes something new. Stage 3, coma condensation and jet alignment. Now comes the part where observation, not imagination, takes over. When astronomers tracked 3i Atlas post-perihelion, they didn't just see a brighter coma, they saw subtle condensation points, dense bright knots inside the coma that moved relative to the nucleus. These microstructures are exactly what you'd expect from controlled venting or localized fracture, a stream of expelled material being illuminated as it trails behind the moving body. Add to this the asymmetry in the coma shape, not the soft radial spread of dust, not the smooth curvature of a tail pushed back by solar wind, but a complex, unbalanced plume, a shape created by directional force. In other words, a jet. Not exhaust, not tech, but fracture physics at scale. And though the word jet makes us think of engines, the physics here is simple. Outflow, thrust. We've already seen this in comets like 67P Churyumov-Gerasimenko. During the Rosetta mission, a single vent can send a body drifting off its gravitational path. Multiply the force, lower the mass, extend the exposure time. Now the deviation isn't a wobble, it's a path, which brings us back to 3i Atlas. The observed acceleration, smooth, steady, Small but real, the spectral color, pale blue, volatile heavy. The coma, asymmetric, uneven, condensation laced. The structure, intact but different. It is not hard to string these threads into a single conclusion. Something cracked, and what escaped changed everything. Where this theory works and where it frays. Unlike the other hypotheses, the fragmentation model gives us something powerful. It explains the transition. It gives us a before, a during, and an after. Before, red-tinged, dust-producing, typical comet behavior. During, thermal and rotational stress near perihelion. After, blue-highlighted, gas-emitting, asymmetrically propelled object natural, reactive, logical. But, as always with 3i Atlas, it's not perfect. If a fracture occurred, why didn't the object shed detectable chunks? Why is the brightness so stable instead of tapering or fluctuating? Why does the vent not appear to degrade the structural core over time? Fragmentation is messy. 3i Atlas is not. Unless, and this is the knife edge of the idea, the fracture wasn't total, but precise. Not the comet falling apart, but a single point giving way and staying open. Like a pressure valve locked halfway. Not catastrophic, controlled by physics, but sustained. And that leaves us here with the same question every comet model keeps circling. How do you get something so wildly active to stay so stable for so long? The fragmentation hypothesis is the loudest, most cinematic explanation. But in the end, it still rests on a structure that breaks without unraveling. And that alone is eerie. Because a crack that vents forever and doesn't destroy the object is not how most comets die. It is how something adapts. There's a narrow edge in science where observation ends and speculation begins. Most of the time, scientists avoid standing near it at all. But occasionally, an object or phenomenon arrives that forces us, not to cross that edge, but to acknowledge its presence. 3. A Atlas is such an object. So far, every explanation we've explored, enhanced outgassing, internal heating, fracture venting, has stretched the known laws of cometary physics, but not snapped them. Yet with each hypothesis, a shadow grows at the edge of the data, a category of possibility that lies outside what nature has shown us before. The idea that some of what we're seeing may not be entirely natural. Let us be clear from the start, we are still well inside the realm of astrophysics. Nothing observed so far requires technology, intention, or engineering. There is no signal, no structure, no broadcast. And until there is, we are bound by the simplest of principles. Extraordinary claims require extraordinary evidence. The problem, if it can be called that, is that the evidence we do have is not behaving extraordinarily clearly. It's behaving almost naturally, almost chemically, almost physically, but not fully. We see a blue spectral profile that is almost consistent with CO+, but shifted by a few angstroms. We see acceleration that's almost explainable by venting, but with a precision that doesn't match typical gas dynamics. We see coma asymmetry that is almost like fracture evolution, but too sustained and clean. There's no outright violation of physics here, only a persistent tension with probability. And it is within that tension, not beyond, that the technological hypothesis must be acknowledged, not as an answer, not as a conclusion, but as a boundary condition. The real question, what would technology even mean here? If one were to frame this as a hypothesis, cautiously, responsibly, the question is not, is this a spaceship? But is there any behavior here that nature cannot produce, even in principle? So far the answer is no. Every anomaly still has a plausible, if strained, natural model, whether through volatile overabundance, thermal triggering, or structural venting. But these models share one thing in common. They each require every parameter, mass, spin, composition, pressure, to land in the rarest possible range. It's like rolling dice 3,000 times and getting 6 every time. Not impossible, but increasingly improbable. The hypothesis of technological involvement, the so-called boundary hypothesis, is not that 3i Atlas is artificial. It is not that it is controlled, constructed, or navigated. It is simply this. If all natural explanations begin to fail, then the burden of inquiry shifts. Shifts, not jumps. If the spectral lines continue to deviate without thermal justification, if the acceleration pattern tightens instead of decaying, if the coma holds its asymmetry past the limits of fracture dynamics, then, and only then, the question becomes scientific. Could a technological process explain this more simply than a natural one? That is the essence of the threshold, not belief, not fantasy, but comparative model efficiency. Science has been here before. When astronomer Tabitha Boyajian first published data on Tabby's star, the strange dimming-undimming object in Cygnus, the scientific paper did not use the word alien, but it did use this exact phrasing. We do not have a fully satisfactory natural explanation at this time. That sentence sits on the threshold. Not sensational, not dismissive, just honest. The same applies here. We have an object moving faster than predicted, brightening post-perihelion instead of fading, a spectral signature one line away from known chemistry, a coma showing organized asymmetry, not random dispersal, a lack of fragmentation despite signs of internal stress. None of this demands technology, but all of it demands attention. The guardrail. Evidence first, interpretation. Later, before anyone, whether scientist or layperson, takes the next step in hypothesis, the ground rule remains. There's no artifact, there's no radio signal, there's no repeating structure, there's no geometry or resonance pattern. All we have is motion, light, composition, reflection, and evolution. All we have is nature, behaving strangely. If a comet can do all of this, then wonderful. We have more to learn from comets. If it cannot, then the question may eventually shift, but not yet. Until the deviation becomes impossible to ignore, science stays quiet at the edge of speculation. Or as one astrophysicist put it, after reviewing the spectral data, it's like looking at CO, but every time the scale settles, the line is crooked. Close, very close, but not close enough to say it's CO, which means we still do not know what it is, but we know what it isn't. And that list is getting longer. So this is what it means to touch the boundary, not to step over it, but to name it and walk alongside it carefully. The simplest explanations still stand, but they are leaning, and if they fall, the question of technology does not enter as belief. It enters as the next most reasonable hypothesis. Fine line, wide sky, waiting data. In any event that straddles the line between scientific anomaly and public fascination, there comes a moment when the data risks being drowned in noise. 3i Atlas has now entered that moment, and the responsibility, whether for seasoned astronomers, citizen observers, or anyone simply curious about the cosmos, is not to silence speculation, but to sort it. Not all questions are equal, not all signals are real, and not all claims are claims that science must answer. Therefore, before we continue the investigation, the first duty is to clear the table, to draw a line in the dust between what is speculation and what is evidence, between what is claimed and what is confirmed. This is not a denial of wonder, it is a discipline of attention, because the surest way to lose a mystery is to mix it with noise so loud the truth cannot be heard. First, the core signals remain. There are 4 data points that remain undisputed, independently confirmed, and repeatedly observed by multiple instruments across multiple platforms. 1. Sustained non-gravitational acceleration. Its speed has deviated from the trajectory predicted by Sun-only gravity. The deviation is measurable, continuous, and not caused by a known gravitational body, verified by ground-based tracking and spaceborne observation. That is a fact. 2. Anomalous brightness curve. Instead of dimming post-perihelion, 3i Atlas brightened. The peak brightness arrived earlier than models predicted and has remained elevated longer than expected. The graph is smooth. The rise, persistent. That is a fact. 3. Dominant blue spectral signature. The object is emitting a spectral profile that leans blue, attributed to ionized gas, but with ratios that do not conform perfectly to known cometary volatiles. The blue is real. The mismatch is real. That is a fact. 4 strong OH emission lines. detected in UV during and after the optical blackout. Swift Observatory recorded clear OH signatures, consistent with active water dissociation. That implies heat, reaction, or internal volatility. That is also a fact. These are the pillars. They are solid. They can be debated, but not dismissed. And now, the other side. Second, the claims that do not currently survive scientific scrutiny. In the wake of 3i Atlas's reappearance, several fringe claims have begun circulating online, in forums, on podcasts, and even, in quieter tones, among amateur radio trackers and conspiracy circles. They tend to fall into two categories. Radio signal speculation, the claim, there's a repeating signal at 1.420 MHz associated with 3i Atlas. Reality, there's no verified detection of any such signal, repeating or otherwise. No Radio Astronomy Institute has issued a statement linking 3i Atlas to narrowband communication in the 20 quarine cm hydrogen band. No paper, no report, no dataset. Status, unverified, a likely rumor. Mothercraft hypothesis, the claim. 3i Atlas is not a comet, but a mothership with distributed probes. Reality, this theory appears to originate from a misinterpretation of the 2017 Oumuamua debate, combined with 3i Atlas's anomalous acceleration. No evidence of artificial structure, no radar reflections indicative of metal, no thermal output beyond physical expectation. Status, speculative, no supporting data. To be clear, these claims are not proven false. They are unproven, and more importantly, unsupported by any primary source. Or to put it simply, no paper, no press release, it goes in the rumor file. It is not an insult to say this, it is a method. If a claim does not come from a telescope archive, a spectrographic dataset, a peer-reviewed analysis, a mission briefing, or a primary source scientist, then it does not earn space in the investigation. Not because it's impossible, but because it's untethered. And untethered claims have a tendency to drag the truth into the mud. Science doesn't forbid speculation, it just labels it. There's nothing wrong with asking if an interstellar object could be artificial. There's nothing wrong with observing a blue spectrum and wondering if it's a signal. Curiosity is not the problem. The problem is equivalence. Not every question deserves equal footing with the data. A hypothesis without evidence is not equal to a hypothesis with evidence. So we do the work, we label. Non-gravitational acceleration, confirmed. 1.420 MHz communication beam, unverified. O emission lines in UV spectrum, confirmed. Mothership deploying probes, unverified. Where the lines are clear, confidence rises. Where the lines are blurred, caution rises. It's not censorship, it's calibration. The role of discipline is to preserve the mystery, not kill it, trahir. Atlas is already extraordinary without embellishment. It moves outside predicted gravitational math. It brightens outside the standard cometary curve. It emits a spectrum that feels almost natural but not wholly so. It vents, glows, sustains, accelerates, and stays intact. We do not need rumors to make this compelling. The facts are the signal, everything else is static. And if there's one thing the cosmos has always taught us, it's that nature, when allowed to speak cleanly, is more surprising than anything we could fabricate. What's the investigator's oath? As of this point in the investigation, we resolve the following. We will not ignore anomalies in the data. We will not assign meaning where none is justified. We will neither suppress the unknown, nor cheapen it with noise. Our North Star is simple. Follow what is real, question what is not, keep the circle tight, let the truth expand on its own. And if something extraordinary emerges, let it earn that status with evidence, not emotion. Because the truth, even if slow, always beats the rumor, in the long run. We are now inside the most important observation window for 3E Atlas, the last period in which the object will be close enough, bright enough, and active enough for meaningful data to be captured before it fades into the outer darkness once more. From now through December 2025, every measurement counts, not because we may get a second chance, but because we almost certainly won't. By late December, this object will have dimmed past the limits of most ground-based telescopes. It will move beyond reliable spectroscopic range. Its coma will collapse. Its trajectory will shift from observable to inferred, which means now is when the work must be done. Now is when the truth is still within reach. The question isn't, can we solve the mystery? The question is, will we measure the right things in time? Here are the 5 critical measurements that must be made if we are to turn anomaly into understanding. 1. Mass and density estimation. Why? Everything about 3 Atlas, its acceleration, its outgassing efficiency, its resilience, hinges on one fundamental property. How much does it weigh? A low-mass object with high outgassing could accelerate easily. A high-mass object would require something far stronger than gas vents to alter its trajectory. Right now, we are guessing. We need to determine nucleus radius, rotational inertia, response to solar radiation pressure, estimated internal porosity. Several clues exist: brightness, acceleration profile, coma development, but none are sufficient without a direct constraint on mass. How to measure? Track changes in velocity with high-precision long baseline interferometry. Compare real-time deviation against gravity-only trajectories. Need to use coma drag and outgassing rate as reverse inputs to infer resistance. The equation is simple: low density plus high acceleration. Natural outgassing scenario becomes plausible. High density plus sustained acceleration. Something deeper is at play. We do not need an exact mass, we just need to eliminate a range. Tas dersta bringt to detailed spectral mapping, 400D and 2500 nanometer. Why? We have a partial picture of 3 IG Atlas's spectral signature, but partial is not enough. We know the blue emission resembles CO+. We know OH lines have been detected. We suspect other volatiles are present. We see a drift in frequency compared to textbook profiles. But we do not yet have full visible to infrared spectrum, line intensity comparisons, time-based spectral evolution. With these, we could finally answer, is this outgassing chemical or thermal in origin? Are exotic or interstellar compounds present? Is the blue signature almost CO, or not CO at all? We cannot argue about cause until we know composition. How to measure? Multi-site synchronous spectroscopy. Cross-calibration between ESO, Keck, VLT, and amateur observatories. Infrared follow-ups using airborne or low-atmosphere platforms, SOFIA type. Breakdown of the rings, peaks, and troughs in the line signatures will either validate the natural model, or prove we're missing a piece of chemistry, or force us to rethink the nature of its emissions entirely. 3. Jet outflow mapping, plume cartography. Why? 3 Atlas's coma is not symmetric. That means it's not passive. Whether caused by a fracture vent, internal heating, or layered sublimation, the outflow is directional, and that direction holds key physical clues. If we can build a map of its jets, we can determine whether the outflow is single point or multi-point, whether the acceleration matches the direction of thrust, whether the pattern is consistent with fracture or function. This could answer whether we are looking at natural fracture jets, sustained pressure vents, or a structured, repeatable emission that is neither random nor purely thermal. How to measure? High frame imaging to track dust, gas, ejection vectors, 2D coma velocity mapping via Doppler shift, comparing visuals from multiple latitudes, Chile, South Africa, Hawaii. Every nozzle leaves a trail. If 3I Atlas has nozzles, even natural ones, we will see them. Mayan 4. Structural integrity and fragmentation status. Why? The fragmentation hypothesis explains much, but assumes we're looking at a body that is partially cracked without fully tearing apart. We must confirm, is the nucleus still whole? Have microfragments detached? Is their rotational wobble consistent with internal shift? Has mass been lost since early observations? Detectable fragmentation would support the venting model. Lower estimated mass help explain the brightness curve. But no fragmentation, combined with acceleration and sustained shine, would point us toward something more controlled, more stable, more unexpected. How to measure? Light curve variability, rotation plus breakup, speckle interferometry, deep imaging for fragment trail detection, IR thermal mapping of surface stress zones. A comet that vents is normal. A comet that vents and stays perfectly intact isn't. 5. Infrared thermal signature, 715 minini. Why? Infrared is temperature truth. It tells us not what the object looks like, but what it is doing. If 3IY Atlas is being driven by internal radioactive energy, chemical heat, post-break residual temperature, external solar reactivity, then we will see temperature asymmetry. A warm nucleus would support the internal heating model. A cold but active nucleus would weaken it. Example test. If IR shows no residual heat, we reduce confidence in the internal chemistry hypothesis. How to measure? JWST, stretch goal, Issei juice, thermal mode, Sophia class IR array or balloon platform, Orneus spectro IR overlays with ground-based scopes. Thermal mapping gives us the single most important clue to origin. Is the object being powered from within or emptied from without? What a sonorif These 5 measurements are not optional. They are the key. We do not need a perfect explanation now. We need the data that will make explanation possible. The goal of the next 45 days is simple. Constrain, eliminate, refine, observe, record. Anything we do not gather now will become, by January, irretrievable. And if 3i Atlas vanishes into the dark with these 5 questions still unasked, we may one day look back and realize that the first interstellar comet to truly behave like nothing we've ever seen was also the one we let get away. As we enter the decisive observation window for 3i Atlas, the lines of potential conclusion are becoming clear. For all the mystery, misalignment, and speculation, there are only 4 main outcomes that this object can settle into. 4 possible endings to a story that so far has walked a tightrope between anomaly and explanation. Each of these 4 resolutions rests on a different balance of probabilities, and each depends on how the data changes, or refuses to change, in the next 45 days. Let us walk them one by one, from the most likely to the most profound. Dareen Barn B.A. The natural adjustment. Outcome. The model holds with tweaks. Probability highest. The first and most conservative resolution is also the one demanded by scientific humility. 3i Atlas is fully natural and fully explainable once the right parameters are applied. In this scenario, the object turns out to be lower in mass than estimated, higher in volatile content, rich in CO, perhaps CO2, with unusual density, and porosity, fragmented internally, or venting in just the right pattern, subject to mild to moderate internal heating from isotopes or solar stress. Once we revise the assumptions, lower density, richer gas balance, rotating exposure, the acceleration, brightness, and spectral deviation all fall into place. Not perfectly, but sufficiently. The blue coma, high CO ionization, the acceleration, outgassing thrust on a small mass, the brightness curve, sun-triggered sublimation of a gas-rich interior. This is the Occam outcome, the explanation that keeps the cosmos untwisted and the textbooks intact. Yes, it's strange. Yes, the curve bends. Yes, the blues are brighter. But in the end, nature has not lied to us. It has merely forced us to adjust our expectations. As one spectroscopist phrased it quietly, raise the CO fraction, lower the density, the math smooths out. Under this resolution, 3i Atlas becomes not a mystery, but a data point. One more example of how interstellar comets are not necessarily like solar system comets, but still follow the same laws. B. The fragmentation outcome. The object breaks apart. Probability. Moderate. In this scenario, the tension resolves not through explanation, but through destruction. The internal pressure becomes too great. The rotation destabilizes. The stress lines give. The object splits, either partially or entirely, and the mystery dissolves into debris. If this happens, we will see a sudden drop in brightness, sharp spectral change, loss of acceleration, a debris trail, possibly a faint cloud in the coma, a fast wind down in observation value. This is the cometary death scenario, not unprecedented, not unnatural, but conclusive. Comets have been known to survive perihelion only to shatter months later as spin, heat, or outgassing outruns structure. If 3I Atlas follows this path, its strangeness will never fully resolve. It will simply end. It will remain a puzzle we were too late to solve. One could imagine the obituary. It wasn't alien, it wasn't engineered, it was just fragile, and the sun was too much. The likelihood is real, but not dominant. The object has shown resilience so far. Stability, persistence. If it were going to die from stress, it likely would have done so already. Yet nature is patient, so we watch. C. The expanded natural model. Outcome. The field moves forward. Probability, low to moderate. This is the outcome not of dismissal, but of discovery. The shift where scientists finally admit, this isn't just a weird comet, this is a new class of object. Under this resolution, 3I Atlas forces us to expand the boundary of natural comet physics, perhaps. The first confirmed interstellar object with internal heating. The first cometary body with perfectly ionized carbon mantle. The first long-lived, low-dust, high-thrust mass driver. A frozen interstellar volatile reservoir, unlike any known body. This ending keeps the mystery, and the science. It means the object is natural, but the category is new. It is the same outcome we received from Oumuamua, a turning point where the anomaly didn't reveal itself as artificial, but as a messenger from beyond the known edge of natural variation. 3I or Atlas, in this path, would teach us something we did not know about. Ice chemistry beyond the heliopause, interstellar nuclear composition, cross-stellar erosion, the extreme ends of cometary physics. This would not feel like explanation. It would feel like expansion, not proof of life. Proof of a larger nature. D. The persistent anomaly. Outcome. The question survives. Probability. Smallest, but not zero. In this scenario, the object does not break up, the parameters do not resolve, the spectral mismatch does not go away, the acceleration does not stop, and yet no natural model explains it fully, and no unambiguous technological signature is found. It does not prove anything extraordinary, but it refuses to be reduced to the ordinary. This is the most uncomfortable ending for science, not because it breaks us, but because it leaves us unanswered. It becomes the tabby star of cometary physics, the wow signal of interstellar objects. It goes on as a file, open, active, uneasy, not alien, not fully natural, just not finished. This ending would mean spectral lines remain unresolved, acceleration curves outlive thermal models, brightness curves defy dust mass estimations. No fracture, no decay, no closure. It becomes an enduring anomaly, a quiet monument to the limit of our current knowledge. It is the outcome with the lowest probability, and also the one with the longest half-life. Mysteries that do not answer, do not go away. Where does the weight fall? If this were a betting field, the smart money is on outcome A, a natural resolution with revised parameters. That is how science works. That is how physics humbles us. But there is something else real here. The probability curve is not collapsing as fast as it normally does. If an object can be explained by a model, those explanations usually firm up fast. That hasn't happened. Not fully. And so all four outcomes remain alive, in different proportions. Cirques entusiasm re war 60%, natural plus adjusted parameters, B 20%, eventual structural breakup, C 15%, new natural category emerges, D 5%, persistent anomaly, unresolved. And whether the ending chooses us or we choose it through observation, the story will tell us more than what 3I Atlas is. It will tell us what we are willing and unwilling to accept. The object accelerates, the clock runs, the window narrows, and the cosmos waits for us to decide whether we want answers or whether we can live with the questions. In the age of space telescopes and billion-dollar missions, it's easy to assume that breakthroughs in astronomy are the result of massive institutions, that the cosmos reveals itself only to those with access to orbital instruments or national budgets. And yet, time and time again, history reminds us of something far more humbling. The sky belongs to all of us, and sometimes it speaks just as clearly through a 6-inch reflector as through a $10 billion satellite. With 3i Atlas, that truth is not sentimental, it's strategic. Because for all its intrigue, strangeness, and interstellar pedigree, this object is still bright enough, still close enough, and still slow enough that amateur astronomers around the world can contribute real data, if they have the right tools, the right timing, and the right mindset. This part of the story, your part, begins now. Says why amateur datum. Matters this time, 3i Atlas is faint enough to slip beneath public media radar, but bright enough to sit in reach of thousands of private telescopes across the world. Its current magnitude hovers around 1213, just inside the detection range of amateur rigs equipped with at least a 6-inch, 150mm aperture under reasonably dark skies. That means, if you have a mid-sized telescope and a camera, you're not merely observing this object, you are capable of measuring it. Brightness, coma asymmetry, motion vector, fragment detection, spectral hints with filters, even acceleration over repeated imaging sessions, all without being a PhD, a grant holder, or a university affiliate. The final truth of 3i Atlas will not come solely from NASA, ESA, or professional observatories. It will come from a constellation of observers, some in Hawaii, some in Chile, some in suburban backyards, forming an unbroken chain of sky coverage across continents and time zones. For once, this investigation is not just being conducted in the polished halls of institutional science. It is distributed, and if you're holding even a modest setup, you're already inside it. With the practical basics, how to start contributing. Here's what you need to join the effort. Telescope aperture, 6 inches or larger. Camera type, DSLR, CMOS Astrocam, or cooled CCD. Sky conditions, Bortle 4 or darker recommended, but urban observers can still participate in stack data. Tracking, equatorial mount with motor tracking. Software, PhD2, SharpCap, Deep Sky Stacker, or NINA, optional but useful. And most importantly, technique. Because 3i Atlas is moving fast, its speed across the sky demands short exposures to avoid motion blur. Think 5 to 10 seconds max per subframe at mag 1213. Stack more subs, win back signal, lose the trail. Mount tracking, quick exposures, outrun the blur. The comet moves, but so do we. What amateur observers can measure. 1. Photometry, measuring the brightness curve. O, does it hold? Fall. Spike. O, your magnitude readings can be logged into international databases. AAVSO COBS. 2. Astrometry, tracking motion against background stars. O contributes to orbital refinement. O helps refine acceleration models. 3. Morphology of the coma and tail. O, is the asymmetry changing? Are there signs of microfragments or secondary plumes? 4. Color data, RGB filters or tri-band capture. O, even a rough color index, BR or GB, tells us about evolution in spectral behavior. In short, you're not just photographing a comet. You're participating in evidence integrity. It's the right disa klabak how to log and share your data. Your data becomes scientifically actionable when it is. 1. Time-stamped. 2. Reference calibrated, stars included. 3. Labeled with equipment details. 4. Submitted to the right databases. Best platforms. Minor Planet Center, MPC. Comet Observation Database, Jerdis COBS. AVSSO for photometry. Cloudy Nights forum threads for peer review. Local or regional astro societies. Discord groups tracking interstellar trajectories. Every tracked frame is a data point. Every timestamp is part of the model. Every stitched log lowers the noise. And this is exactly what makes amateur astronomy a force. Not one telescope, but many. Not one image, but aggregate truth. This is how you become a line in the paper. It sounds romantic, being part of a discovery. But this isn't fantasy. Astronomical history is full of amateur contributions turned into professional citations. Icaron 1995 01 Hale Bopp, co-discovered by an amateur. Comet Lovejoy, discovered by a warehouse manager with a simple scope. SN 11987A, witnessed by a guy with a backyard reflector. Even the first observations of 2IB Borisov were confirmed by amateurs within 48 hours of discovery. Science is large, but the sky is larger, and it needs more eyes than any agency can provide. We we're not just watching the sky, we're watching the evidence tighten. The next 45 days are not about fame or being first. They're about coverage, redundancy, commitment. Imagine what happens if one observer in Chile catches a brightness dip, another in Italy confirms no fragment loss, a third in Texas logs a subtle coma tilt, a fourth in Vietnam detects a color drift overnight, and a fifth in Namibia captures it all with IR. That's not speculation. That's verification. That's how a mystery becomes a measurement. Call to the sky. If you're watching this and you own a telescope, you're already part of the network. If you're watching this and you don't, you're still part of the signal. Like the data, share it, follow the updates, comment, know someone with gear, tag them, have access to dark skies. Show up. Let this be the generation that remembered. The frontier of astronomy is not a gated laboratory. It is a sky that lets anyone willing stand underneath and record what they see. Stree's Atlas is not asking for believers, it's asking for witnesses. And if you're holding a 6-inch scope, the sky has already chosen you. In the presence of the unknown, the most important tool a scientist has is not a telescope or a simulation. It is the ability to doubt with balance, to practice what can be called double skepticism, the mindset that refuses both the sensational and the dismissive, that stands calmly between wonder and assumption, that chooses neither fantasy nor rigidity, but the measured path of evidence. With 3i Atlas, this posture is not optional, it is essential, because this object sits at the crossroads of imagination and analysis, close enough to what we know to be relatable, but far enough off-model to be unsettling. And in that tension space, only two things can go wrong: believing too much or believing too little. This is why double skepticism is the only legitimate scientific response. First skepticism, distrust the sensational. There is a temptation, built deeply into human psychology, to leap toward extraordinary explanations as soon as something feels unfamiliar. We are pattern-making beings, and when the pattern fails, the imagination fills the gap. A comet accelerating beyond what gravity allows, a spectrum that glows blue instead of dust red, a brightness curve that peaks instead of collapses after perihelion. It's all too easy to turn that curiosity into conclusion, to say, this isn't a comet, or worse, this must be artificial. And that's where the first skepticism steps in, not to shut down curiosity, but to shut down premature belief. This is the voice that says, extraordinary claims require extraordinary evidence. Don't confuse anomaly with intention. Mystery is not a blank check for imagination. Just because something might be unprecedented does not mean it is unnatural. Just because we don't understand it yet does not mean it escapes nature. This is not cynicism, it is integrity. A scientist must never fall in love with a hypothesis more than with the truth, so we stay patient, we stay grounded, we demand proof. Second skepticism, distrust the comfort of the familiar. Yet there's another danger, just as real, but quieter, the danger of believing that everything must be normal, that whatever looks strange is simply a misunderstanding, that the model is always right and the data is what needs to adjust. This is a different kind of bias, not toward wonder, but toward inertia. We are taught to trust models, to trust precedent, to trust equations. And as a result, we risk missing the moment when the universe is trying to show us something new, not beyond physics, but beyond our expectations of physics. The second skepticism protects against that. It asks the uncomfortable questions. What if the model is incomplete? What if the explanation requires expansion, not correction? What if nature has more range than we think? Double skepticism is the realization that both error and breakthrough hide in the same place, inside the things that don't quite fit. When 3i Atlas glows blue but doesn't match standard carbon ion profiles, when it accelerates smoothly but shows no obvious fragmentation, when its brightness curve behaves like a system, not a flare, we don't jump to alien, but we also don't force it into comet as usual. Instead we say, not matching perfectly miracle, but something we can ignore. It is in that gap, between too early belief and too easy dismissal, that science grows. Where the two skepticisms meet, the evidence boundary. The path forward, then, is neither to worship the anomaly nor to bury it. It is to walk alongside it, measuring and questioning. Double skepticism tells us every hypothesis must be tested. Every model must be evaluated against reality. Every claim must survive contact with data. Every unexplained pattern must remain open, but not declared. It is an ethical stance. Stay curious, stay doubtful, stay alert. And most importantly, let the evidence decide, not the story you want to tell. 3i Atlas doesn't need protecting from imagination. It needs protecting from interpretation without evidence. And that goes both ways. No hype without data. No dismissal without proof. We must not romanticize this object, but neither should we trivialize it. It has earned attention, not because it is extraordinary, but because it is not yet fully explained. And until the day it is, we owe it honest observation, not convenient classification. Bescoing dears the calm declaration of scientific responsibility, so we stand here. As the countdown to December 19th begins, and we state, we do not yet know what 3i Atlas truly is. We do not have a complete natural model that explains all its traits. We do not have valid evidence of artificial origin or intent. We do not reject any hypothesis. We rank them according to evidence. We will continue to gather data, not conclusions. This is not indecision. This is discipline. We are not confused. We are methodically uncertain. And that is the foundation of every discovery. As physicist Lisa Randall wrote, when we are too sure, we stop looking. We will not stop looking. Not yet. Not while the light curve still climbs. Not while the coma still tilts. Not while the equations still tremble. We don't need to solve the mystery today. We just need to refuse to lie to it. Scharf for exacter the scientist's oath, doubt twice. So let this be the method we carry into the final phase. Doubt the sensational, doubt the dismissive. Let reality choose the path. That is how we honor both truth and wonder at once. Not with answers on demand, but with patience, vigilance, and an uncorrupted curiosity. The universe is speaking. Our job is not to finish its sentence, but to hear it clearly. We have now reached the edge of the observation window, the final stretch of time in which 3i Atlas will remain bright enough, close enough, and active enough to reveal the truth that it's been carrying across interstellar space for perhaps millions of years. A truth now slipping steadily toward the outer dark. Between now and December 19th, 2025, we stand inside what astronomers are already calling the golden window. A rare and irreversible moment, one that will not return, one that is already shrinking with every passing night. This is the last chapter of the first phase. The object will not stay this bright, the coma will not stay this active, the opportunity will not stay this open. When the clock strikes December 19th, all we will have left is what we've measured, not what we hoped for, not what we feared, not what we guessed. This is the countdown, not to impact, not to revelation, but to resolution. And the question before us now is not, what is 3i Atlas? The question is, will we stay long enough, watch carefully enough, and think clearly enough to find out? What to watch in the final days. There are 3 scientific threads still unspooling, 3 pillars of observation that will define how history remembers this object. 1. ESA's JUICE spacecraft, positioned with a unique solar relative vantage point. JUICE will continue to record thermal, optical, and mid-range spectroscopic data as the object fades. Every file they downlink might carry the spectral line or heat map that tips one hypothesis over another. 2. NASA's SWIFT Observatory UV X-ray. SWIFT will keep searching for faint OH emissions. If those detections continue, or suddenly stop, that will tell us whether thermal activity is fading or shifting. 3. Peer-reviewed papers and preprints. In the coming weeks, the first formal analyses of 3i Atlas will begin to hit Ariyarchiv, MN Reyes, and PSJ. These papers will not settle the debate, but they will mark the transition from anecdote to literature. This is how a mystery becomes a milestone. Do not just watch the sky, watch the data, watch the language, watch the debate crystallize. In the next 45 days, the most important thing isn't what you believe, it's whether your belief is attached to evidence. Mystery does not need mythology, it needs clarity. Scheidalishki nein, egerm, your role in the final arc. You may not hold a PhD. You may not control a satellite or command a spectrograph. You may not contribute a single pixel of image data or a single digit of measurement. But you have something as crucial as the instruments, attention, because this countdown will not be remembered solely in papers or archives. It will be remembered in the collective attention of those who chose to care, those who paused in their day, turned their gaze upward and said, if something new is happening in the sky, I want to know. So here is the call. Follow every official update from ESA and NASA. Track the journals and preprints. Share every new dataset and analysis that passes peer review. Question every claim that isn't supported by instrumentation or primary sources. And above all, commit to staying through the end. If you've watched this far, don't walk away before the verdict. Because this is the moment where speculation becomes conclusion, where mystery meets history, where the archive writes its entry. The gift of witnessing. Every once in a while, the sky does something that challenges both what we know and how we know it. When that happens, the task is not to solve it alone, but to stay with it until the evidence decides. 3i Atlas is not a Hollywood event. It will not explode. It will not impact. It will not signal. It may even fade quietly. But in that quiet lies the possibility that we will catch the first interstellar object ever observed to defy not physics, but expectation. Or perhaps the first interstellar object that did nothing extraordinary at all, and thereby reminded us that wonder lives not in what is magical, but in what is measurable. Either way, it matters that we were here. As one observational astronomer said to her students last week, you don't get to choose when the universe goes strange. You only get to choose whether you're paying attention when it does. A final call before the sky closes. So here is the close, spoken not in drama, but in respect. We are counting down not to a climax, but to a clarity. December 19th is the end of the window. The last day 3i Atlas will speak with strength, the final chance to catch its story before it dims beyond our reach. Mark it on your calendar, write it in your notes, set a reminder. Set 2. And if you've walked with this investigation from the first brightness anomaly to the break behind the sun to the blue glow and the shifting coma and the impossible curve, then don't leave before the last measurement is in. Because science is not a race to answers, it is a vigil, held in daylight and starlight, in cloud gaps and telescope domes, in spreadsheets and comment threads, in the shared conviction that the truth is worth the time it takes to see it. Shabbat. Yet sometimes the sky tells us a stranger story than we expect, and sometimes it only does so if we stay until the final line. The countdown is active, the object is fading, the data is still speaking. Stay with us, stay awake, stay through the end. December 19th, 2025. One way or another, you will remember that date. Because by then, the sky will either have told us what 3i Atlas was, or it will have left us with a silence loud enough to ask again.